6.4, use inverse functions. Inverse relation. This is a relation that interchanges the input and output values that means they switch the x and the y. Inverse function. This is where the relation and its inverse are both functions. Okay, let's go back to our definition of function. Function is if we have ordered pairs, we can't put in a 3 for x and get out a 0 and then put a 3 in for x again and get out a different number. So that's how you know whether it's a function or not. If you graph it, you can also use the vertical line test. You can't make a vertical line through 2 points. Okay, example 1, finding the inverse. First thing you do is you write the original equation. Now you're going to switch the x and the y. So we're going to put x here equals 7y minus 4. And then I'm going to solve for y by itself again. So I'm going to add 4 to both sides. So x plus 4 equals 7y. And I'm going to divide by 7. Get x plus 4 divided by 7 equals y. And that's the inverse of it. Functions f and g are inverses of each other, provided that the composition of the functions, one inside the other, both ways, both just equal x. The function g is denoted by f of negative 1, and it's read as the f inverse. So let's verify that f of x equals 7x minus 4, and the inverse equals 1/7 x plus 4/7 are really inverses. So to do that, we make a composition of them, and we write down the f of x first. So 7, we're going to leave our spot for our x minus 4, and then we're going to put our f of negative 1 in here. So 1/7 x plus 4 over 7. And let's see if that equals just plain x. So what's 7 times 1/7 x? That's x. What's 7 plus, or times 4/7? That's plus 4. Then minus 4. Plus 4 minus 4 is just 0, so that is just plain x. Now we have to do it again the other way to show that they're really inverses. So let's start with the 1/7 and leave our spot, plus 4/7, and then put it in our 7x minus 4 and solve this again. So 1/7 times 7x is x. 1/7 times negative 4 is negative 4/7 plus 4/7, and that equals x. So they are inverses of each other. Okay, try this checkpoint and then start the video again when you're done. Alright, example 3. Find the inverse of f of x equals 4x squared. So, we're going to write the original function, replace f of x with y, and then switch the x and the y. So now x equals 4y squared. We're going to divide each side by a 4. So x over 4 equals y squared. Then I'm going to take the square root of both sides. Square root of y squared is just y. Square root of x, what's the square root of 4? 2. Now, this is an even function, so I'm going to put plus or minus here on the outside. Because when I draw the square root sign, I have to put plus and minus. Now, the graph of this is kind of weird and it's a little bit confusing. So we're not actually going to graph this. Okay, let's go down to the horizontal line test. The inverse of a function, f, is also a function if and only if no horizontal line intersects the graph of f in 2 places. So the vertical line test is for a function, and the horizontal line test is for an inverse. So they both have to work for an inverse to be a function. So this one works because you can pull in any line down here and it doesn't cross twice. And then you can also pull any line here and it doesn't cross twice. But this one doesn't work. Okay, example 4. Find the inverse of a cubic function. Well, again, we're not going to worry so much about its graph. And let's go down here and just find the inverse of it. So we're going to write the original equation, put in the y, and then switch the x and the y. So how do I get my y by itself? I'm going to subtract the 3. Then I'm going to multiply both sides by 4 to get rid of that 1/4. So 4x minus 12 equals y cubed. Then I'm going to take the cubic root. 4x minus 12 equals y. And I don't need to worry with plus and minus this time because it's a cubic root. And that's the inverse of it. Okay, go ahead and do the checkpoints at the bottom.